All right, guys. Sorry if that last video kind of felt like I got cut off. I needed to pause for a second because I'm doing this at school during lunch. So anyways, we just got through this. And then as I thought through it more, I think this next video, I'm not going to try the practice problems yet. I'm going to make that into a completely separate video. So I'm actually going to jump ahead to 1, 2, 3, 4, 5, 6 pages in, and we should have the rates, ratios, and percents stuff so that we can talk about that. So firstly, I know I have this huge box here for rates. It's really not that complicated. Really all a rate is kind of a slope number or a fractional number. So like that direct variation equation that I talked about in the previous video, y equals k times x, that can be rewritten as like k equals y over x. This is the perfect example of a rate. If you think about the direct variation equation, I'm just more of a visual person, so like showing you with a picture I think will be a little bit easier for me, maybe for you too if you're a visual learner. A direct variation equation always has to go through 0, and it moves up at a constant rate. But the other interesting thing about it that is really useful is that no matter where I go on this line, when I do sort of this slope triangle, it's always going to reduce to the same amount. So no matter where I go, it can always just do y over x, and it's always the same. So that's super helpful because like if I know one point on the line, and I know the y value of another point on the line, I can solve to find the x values because all of the rates, all of the slopes, all have to equal this constant k. That's not really the case with a linear equation that has a y-intercept of something other than 0 because it was added up or subtracted down. Those rates aren't really related by the same ratio every time, which, as I'm using that word ratio, let's talk about it. So a ratio is just a shorter version of the word rational, and rational numbers are just fractional numbers. So like a over b is a really good example of a ratio. You could also write that same thing as a to b, like with the colon in between, or sometimes they simply just write it a to b. Okay, so an example of how we might write a ratio. If there are 5 boys to every 4 girls in class, the ratio of boys to girls is 5 to 4. That's all well and good. And like in this example here, I can't really assume that there are more people, but a really good example of where a ratio can be helpful is like if the ratio of boys to girls is 5 to 4, but there are 32 people in class, I can figure out exactly how many boys and exactly how many girls, because another super important thing about a ratio is that it's always reduced. So again, thinking about that example that I just said, if I know the ratio of boys to girls is 5 to 4, and then there are 32 people total in the class, this ratio wouldn't work. But I could do 5 times x plus 4 times x equals 32 to find the total amount of actual boys and girls in the class, because that x represents this reduced out factor that I don't know. Okay. Another way we could write a ratio is ratio of boys to total. And so boys to girls was 5 to 4. And assuming there are no more, it would be 5 to 9 like that because the total is 9. Now, a proportion is also an important thing to talk about when we have ratios. And that's just when I set 2 ratios equal. So 2 ratios that are equal. Oop. So it could be something like as simple as half equals 3/6. And like obviously, so we can tell obviously because as I go from here to here, I times by 3, and as I go from here to here, I times by 3. Or thinking about it backwards, I divided by 3, I divided by 3. Or usually what happens when I have two fractions that are equal or a proportion, usually I cross multiply. So a lot of us tend to, and this is just from my experience, when we see two fractions together, we always think cross multiplied. You truly only do that when there's an equal sign between them. If you have two fractions being multiplied to each other, you don't cross multiply, you cross divide, but with an equal sign between cross multiply, and here we get 6 and 6, and it does. That's not very helpful. But cross multiplication is super helpful if I have something like this. So I can multiply across, like diagonally down, and get like 280 equals 28x. But I can also do some of that sneaky stuff like I was showing you before. Like I can see that from 4 to 28, I had to multiply by 7. Or like backwards, like 28 divided by 7 is 4. And so the same thing is true here. I can think what times 7 is 70, and that would be 10. So you can sometimes do proportions really quickly and easily if you can see like a common multiple or a common divider, depending on which way you're going. But if it's not super obvious and super easy, you can always do this cross multiplication. So percent, and then I gotta go back and do that example, but let's talk about percent. A percent is just a number compared to 100, so it's really a ratio that's always compared to 100. So a percent is a number compared to 100. Actually, I don't want to do this example now that I'm thinking about it. Don't worry about it. We're going to do a lot of ratio examples in just a little bit. So a number compared to 100, we always write it like over 100 like this, but truly we usually turn that into a decimal. Or I mean, like if you're looking at it as a percent, that's fine too, but to use that number mathematically, you need to be looking at it as a decimal. So to change from a percent to a decimal, which we do have to do if I want to use it in any sort of mathy way, we need to move that decimal 2 places, and it's 2 places because there are 2 zeros. So for example, if I had 7%, that would change to boop, boop, 2 places left. If I go over something that's not a number, I need to put a 0 there, so 0.07. Or I can go the opposite way as well, so to change from a decimal to a percent. So if they're asking me to find a percent and I put it over 100 and I divide and I get like the decimal 0.21, to change that to a percent, we go doot, and you'd have 21%. So easy peasy. But something that's maybe a little less easy to think about is percent of change. So when we have percent of change, this is something that, I mean, personally I see a lot, like if I'm out shopping or something, not to be like, oh, I'm shopping, but if you go out shopping and you see that an article of clothing or an item has been marked down or maybe even marked up for some reason, you might want to find out that percent of change. So to find the percent of change of something, you would do the increased amount over the original amount. So to find the increased amount, you really have to subtract what it is now from what it was. And so the difference, and then the original amount goes on bottom. And then a percent decrease is the same thing. Really, you're finding the difference of the OG price and the current price on top. So OG minus current. And if that number happens to be positive, then it was increase. And if it happens to be negative, it's decrease. You just kind of want to ignore the sign there. And then you always divide by the OG amount, the original amount. So yeah. Oh my gosh, I'm going to stop this video here and do all the examples in the other one. I think that's probably smarter. Yep.